Welcome back to Mining Stock Education. And in today's episode, we're going to be talking about till and soil samples. I asked Dr. Rob Stevens, the author of Mineral Exploration and Mining Essentials, to come back on the show to give us his take on what we as gold and commodities exploration speculators should be looking for as these companies are defining drill targets. So Rob, welcome back onto the program and please take it away.
Yeah, perfect, Bill. Thanks very much. I appreciate the opportunity to talk a little bit about exploration again with your listeners. Yeah, so today I wanted to talk a little bit about till and soil sampling and how that's used in mineral exploration. You know, how to look at it and evaluate it from an investor point of view. So we're going to touch on a few things here. We're cover off what is till and soil sampling, how are people sampling that material, and then how do you analyze it? Once you've analyzed it, how do you interpret those results? And then what do exploration companies do with that? What are the next steps from those results? So we'll kind of step our way through those different components of it. So, and there's a copy of my book you can see up at on the first slide there, but let's go over to this model first. I want to just talk about, why would somebody collect soil material or till material? And so first, let's talk about soil. The way you have to think about it is whenever a rock is exposed at the surface of the earth, that rock is subject to weathering and erosion, and it starts to break down. So if you have a gold deposit that is also exposed at the surface of the earth, it will erode and break down, and that broken down rock becomes part of the soil material. And soils actually move, even though we might not see that when we're out looking at them. They do move in the scales of years to thousands of years. And so when the gold deposit breaks down and becomes part of the soil, and then the soil starts to move generally downslope and away from that deposit, and the soils mix, it means if you go and you collect a sample of that soil material and then send it to a lab for analysis, if there was a gold deposit that eroded, in the case of soils generally upslope from where you collected your sample, you should be able to detect that gold deposit in the soil material. So it's really used where you don't have a lot of rock exposure. I mean, ideally you want to be mapping and sampling rock directly, but where that's not the case, where you have thick soil material, you can sample the soil as an indirect way of looking for deposits in the underlying bedrock. So that's soil material. Soil is sort of locally derived from the underlying bedrock. For those of you who are seeing this on YouTube, I've now just moved over to another slide to talk a little bit about till sampling. So what is till material versus soil? A till is a term that's used for sediment basically derived from glaciers. So the way to think about this is glaciers are really effective at erosion. As a glacier flows over the surface of the earth, it will break down and erode the rocks that it's flowing over top of. And those pieces of rock that are getting broken down, including, for example, something like a gold deposit, those pieces of rock get incorporated into the ice, and then the glacier flows and carries that rock down the ice direction. Eventually the glacier melts, all of that rock that's caught up in the glacier drops out, and you can end up with these thick deposits of what's referred to as glacial till. And so one of the real differences between soil material and till is soil, as I mentioned, is kind of locally derived from the erosion and breakdown of the underlying rock, whereas glacial till is deposited by a glacier, and so it could be transported a long way. Glaciers can flow for tens of kilometers, for example. So if you find an anomaly in a till sample, or gold values in a till sample, one of the tricks then is, well, how do we trace that back to the source of that gold in the till material? And there's various ways of doing that. One of the things that happens when glaciers flow over rock is they create scratch marks in those rocks, glacial striae, we call them. And so you can map out those scratch marks and they actually tell you the flow direction of the glacier. So if you find a sample, let's say with high gold grains, you can map out the flow direction of the glacier. And the idea is then to trace that sort of back up the flow direction to hopefully find the source of that, that gold that you found in the sample. So it's a little trickier with glaciers because tracing it back to that source can be harder, definitely than soil sampling. So let's just think about sampling then. How do we sample this material? So soil material is generally sampled by a couple of individuals, and I've changed over to a new slide here showing some people collecting samples. The image on the right is a couple of guys collecting a soil sample. You really just collect a sort of a small handful of soil material just below the surface. That material then goes to an analytical lab for analysis, and they do a geochemical analysis to identify the concentration of gold in the soil sample. Till, a little bit different because you may be doing some different analysis with your till. And one of the things with this glacial till material is it can be really thick. Sometimes 10 meters thick, 20 meters, 30 meters thick. So where you have really thick glacial till, sometimes people will use an auger or even a reverse circulation drill in order to get down to the bottom of the till and ideally collect a sample from what's referred to as the basal till, or that glacial till material that's sitting close to bedrock. The reason for that is that till material close to bedrock is often moved the shortest distance. So it allows you to hopefully trace back the source of any gold anomalies that you find because it hasn't traveled quite as far. So again, when you have really thick till, I mean, realistically, you can't dig with a hand anything more than maybe half a meter or a meter tops. So if you have thick till, then you'll often use augers or drills to get down to that deeper material. Soil, you don't have to worry about that quite so much. In terms of the pattern that people collect soil or till material on, generally on a grid pattern is what people will do. So for example, they will have grid lines that might be 50 or 100 meters apart. And along those grid lines, they'll collect a sample every 25 or 50 meters. Part of the reason for doing that is just to have a regular distribution of samples across the ground, which then when you get the results and analyze them, it allows for a very consistent pattern of samples and it's much easier to interpret. If you didn't use a grid, you might have your samples sort of randomly spaced. And who knows, you might miss something in that random spacing. So grid samples just allow for a very systematic pattern of sampling and then hopefully a systematic means of identifying any anomalous samples that you collected. In terms of sampling then, so we've kind of looked at what is till and soil and how is it formed, how do we sample it in the field. So let's look at now how we analyze it, and then we'll go to interpretation and next steps. So in both types of samples, probably one of the most common, certainly for gold, is to do a fire assay. So you take the sample that has been collected, they dry it and then homogenize it in the lab. So they mix it very, very thoroughly. So the whole sample is homogenized. And then they actually just take a very small split, like a few grams from that sample, and they'll do a fire assay. And the fire assay will give you a grade of gold in those samples. Now, the grade that you might see companies reporting on for soil samples can be really low. I mean, sometimes it's in parts per billion, gold in parts per billion. And that's because you have to think if you've got a gold deposit in your rock, and that deposit, as well as all the rest of the rock, is eroding and breaking down and becoming, let's say, the soil material, the deposit is really diluted by all the non-mineralized rock. So the actual grades that you will find in soil material can be very, very low. And you're not mining the soil material, so that's fine. It's really a means of helping you identify a deposit rather than the absolute grade being significant. The other thing with till samples, though, that people will do is they will also do gold grain counts. So in this case, they will take a really large sample, and that's a case of the image here on the left. A big bucket of sample. They'll take that to a lab, and in this case, what they do is they separate out the high density minerals or the heavy minerals, and that's because gold is a very, very high density element. It's about 6 times as heavy or as dense as almost all other minerals or elements. So they do a density separation. You end up with this sort of small split that they call it. And out of that, a person actually will go and separate out visually using a microscope the gold grains that are in that sample. And so they actually do a gold grain count. And in this case, they would report it as, this sample, they have to equalize it out to weight so that there's a constant sample weight. But this sample had 10 gold grains, over here we had 20, and over here we had 250. Obviously, where there's 250 gold grains, you're probably closer to a source or a more significant potential deposit. And in those cases, people also look at the shape of the gold grains. The idea being if they're what's referred to as pristine grains, really angular, it suggests that the gold has not traveled very far from its source. Versus really rounded or folded up gold grains, those often reflect grains that have traveled much, much farther. And so it helps a little bit with that process of trying to trace back to the source of the deposit if you identify gold in your till sample. So there's kind of a couple of different ways there that people will look at analysis. I would say by far the most common is to do a fire assay or a geochemical. But as I mentioned, with till, people will also do gold grain counts. Now, when it comes to interpretation, then, what do the geologists do and how do they make sense of all of this? Again, the whole purpose of this is kind of an indirect way of identifying a deposit that lies underneath an area covered in soil or covered in till. One of the things they'll do in this image here that I've just moved to shows a grid pattern. This is actually the results from a soil survey program. What you can see is samples collected on a very regular grid pattern here. And then the key is to identify what's referred to as anomalous samples from background. So this is where the absolute value is not always that important. And the reason I say that is every single soil sample that somebody would collect will have a little bit of gold in it. Not very much in most of it, but it'll all have some gold. And so what the geologists do is they try to identify what is the background level of gold in the area that you're exploring. And once you know that, I think in this image, it's suggested it's about 50 parts per billion gold in the sample. Once you know that, that's the background level, you really look for the samples that give you much higher values. And things that are a lot higher than the background, those are then anomalous. They're higher and distinct from the underlying or from the average soil and may represent a nearby deposit. So they do statistical analysis to sort of separate background from anomalous. In this case, they've just plotted up each of the individual samples along the grid pattern and color coded them with the higher values having a nice red color because they stick out, and the really low background ones just being given a white color. The other thing people will do, and I've just moved over to another image showing, in this case, it's actually copper because soil and till sampling don't just work for gold, they'll work for other elements as well. But this is a color contour map. And in this case, we don't actually see the location of all the samples. But if we look at a scale at the bottom, we've got 1,000 meters at the bottom. So this is actually representing quite a big area. So I would guess thousands of soil samples were collected in this area. They analyze them, they get the results, and then they create a color contour map. And the idea with a color contour map each of the colors represents a certain grade of gold. And so almost always the hot colors, the reds, that kind of thing that you would see on a map would represent the high values of gold, or in this case, copper in soil. And then the cool colors represent lower values. So it's a really nice visual way to identify the areas with the higher grade samples. And it's very effective for geologists, and also companies. You'll see them put out maps like this a lot on their website and press releases, because they're also quite a good way of helping others to understand the kind of work that they're doing. So then if we get to the sort of last part, what do you do next? You found a really nice anomaly with high gold values in your soil or in your till. So the trick is, where did they come from? Where can we then trace that to find the deposit? So first thing they might do is tighten up their grid spacing or their soil sampling. So really increase the density of their samples, which will allow them to better define those areas with the higher features. If we don't have too much of a thickness of soil or till, trenching is a great way, and you'll get there and just basically dig down beneath the soil of the till to the bedrock. Because really that's what you want, is the bedrock and the potential for a deposit there. So wherever possible, get down to the bedrock and try and see what the rock itself looks like, and whether you can find the deposit from there. You may want to combine your soil material with other exploration methods such as geophysics. So as an example, gold deposits or many gold deposits can be found in fault zones. And fault zones are these breaks in the rock. But in geophysics, fault zones can often show up as fairly distinctive linear features in the geophysical results. And so if you combine your geophysics, where you have a really nice linear feature, with your soil material or your till, where there's a really high gold concentration, and the two of those are coincident with each other, that can end up being a really good target. And generally, exploration use that all the time. It's the more data and the more information you can put together, you're just better understanding the area, and hopefully then making a discovery. And of course, drilling. Some people will drill off soil anomalies or till if there's really no other alternative. But again, if you can get soil plus geophysics and they coincide, and you're in the right kind of rocks from whatever rocks were around, you've been able to identify the types of deposit, then of course you're going to drill. That's always the truth, right? Do you actually have something there or not? So yeah, so there's kind of a quick whirlwind through sort of soil and till sampling. It's a great technique. It's one of the real standard ones that's out there. You have to modify it and adjust a little bit depending on the environment you're in. Of course, glaciers aren't everywhere, so glacial areas you have to consider if you have till or not. Tropical areas are even a little bit different because of the heavy weathering that goes on and the way soils are generated in tropical areas. The geological team needs to modify their approaches a little bit, but they're all kind of ultimately the same. It's trying to find that hidden and buried deposit beneath the soil material. So I'll just end up with this slide, which has my book on it again, and find information on that, and I have some online courses as well. If people are interested in, they can find that at MiningEssentials.com. But anyway, yeah, thanks, Bill. And I don't know if you have any questions or any follow-up that
Yeah,
you wanted to ask.
a few questions. First of all, thank you. And as I've said numerous times on this show, that's the best book you want to get if you're wanting to learn how to speculate in early stage companies in the mining sector. So, what's the history of till sampling? Because we know the old timers would see outcropping and go from there. But before modern technology, can you give us a little bit of the historical backdrop here?
Yeah, I mean, you're right. Back with prospectors and such, I mean, they're not normally paying too much attention to soil or till material. They're going to be looking at the rock and trying to identify those rocks that might host deposits. Um, It is a technique that has been used, for decades, longer than that even. But a couple of things I would say is analytical technology has really improved, let's say the last 50 years or so, which allows the analysis of very low grades or low concentrations of something like gold and soil material down to the parts per billion, which is a, a very, very low concentration. So it's actually allowing companies to identify areas with gold anomalies um, that are insignificant, that actually, result in the discovery of a deposit. But the grades in those samples is really, really low. And so before the analytical methods were improved to the point of being able to detect gold and distinguish grades at those very low levels, it wasn't as useful. I mean, still helpful for sure, but and not everybody, of course, will use soil sampling in their program. If you're really lucky to have tons of rock exposure, that may be sufficient and you won't use soils. But I think you'd find that the majority of projects at some point are doing some soil or till sampling as part of it because rock just is not exposed everywhere. So.
Well, what about the assay labs? Can any assay lab prepare the results for soil or till samples, or do you have to be qualified as a lab?
I would say that most of the labs. I mean, you always ideally want to go with a registered or qualified lab, just so you make sure you're getting good results. And similar to rock sampling, when people do soil samples, they often will include in a batch of samples duplicates and blanks and other checks just to ensure that the lab is giving them the results that they expect and they can rely on. So a duplicate, they'll put two of the same sample and you should get the same result pretty close anyway. If not, then something's up. The fire assay method that is used primarily to identify gold, um, that's such a fundamental technique that pretty well every lab will do that. So what you do find though is that in different locations or even countries, there'll be preparation facilities. So the soil will go to a local preparation facility. It's dried, it's mixed up and homogenized, as I mentioned. And then they might just take a couple or 3 grams from that, which is what gets analyzed. And then that actually goes to a central lab that might be in a bigger city or that kind of thing. So they do the prep locally, reduce the size down to a small, very small piece. And then that goes to the home lab kind of thing for analysis.
So there should be a quality control person overseeing the preparation of the soil and till samples, right? And I bring that up because
Mhm.
in the last week there was an exploration company that was putting out excellent results, but they had to put out a press release saying our core was biased because
Mhm.
the core, that the half that they kept didn't produce the results of the half of the core that they sent to the assay labs and those results that they initially published. So human
Okay.
bias can even come into
Yeah.
play with core, but maybe not so much with till samples. Is that right?
Yeah, I mean, it's hard to know what's in those samples. They don't look like very much. Of course, with core, you're looking at the rock and you may be able to identify a vein or even visual gold, VG as they call it, in the core itself, which could lead to some bias. But really, standard, I would say, in exploration projects, it is really important to have a quality assurance and quality control program and procedures in place that are for the field personnel all the way from when the sample was collected until you get the results back from the lab. Things like you can trace it all the way through, you know exactly how it's been handled, but also, as I mentioned, duplicates, things that are called standards. Companies can buy material that has a really well-defined geochemical um, um, composition, and they send those in as well because they know what result they should be getting, and that way you can confirm that the lab is operating. But it is important to have those quality control procedures in the field so that you avoid bias. That doesn't do the company any good. There may have been no intent in the example that you gave, but it never looks good if you have to put out a press release and start qualifying the results that you release. That just it's going to get everybody skeptical.
And it
So
doesn't help the industry on a
no,
large
no,
scale.
for sure.
Yeah.
Yeah, yeah.
So What about the quality of a golden till anomaly? Now, does it mean more to you as a mining speculator if it has the geophysical overlay? That's what, if you have the golden till anomaly plus the
Mhm.
geophysical anomaly, is that what gets you excited the most if you're going to buy shares in a company that's about to drill this?
Yeah, good question. Like always, not necessarily a straightforward answer on that. I mean, what I like about soil samples and till samples is they're geochemical. So they're giving you gold grades, which is always great. Even if those grades are low, it doesn't matter. If you've separated out from background and you have an area with distinctly much higher grades in your soil or till material, that's really relevant, and that, to me, I'm interested in that on its own. Now, as a geologist, I would also want to look at the environment or the area where those samples were collected, because I know that um, there are some areas where soil sampling works really, really well. I mean, there's a type of soil that people refer to as residual soils, which are really derived right from the underlying bedrock. And so if you got a really high gold anomaly in these residual soils, I mean, it's coming from something really nearby. So I don't know that you would need any other, geophysics or other exploration data. In other cases, if it's till, where samples could have been transported some distance by the glacier, where your till material is thick, so you really haven't had a chance to see the underlying rock, in those cases, I might be a little bit more cautious on that and would like to see those soil anomalies or till anomalies correlated with other exploration information. So such as geophysics, um, sometimes you can do structural mapping, with whatever rock is exposed. You've got a good enough understanding of the geology that you can correlate, those gold anomalies with the geology, with the geophysics. I mean, always the more information you have and the more layers of data that you can put on top of each other, the better it is. It's tricky. Exploration is a tricky business. It's hard to discover things that are buried beneath the ground, even if the rock's exposed. The deposit is still beneath the ground. So I'm a fan of the more data, the better, and the more layers you can get, the more confidence you're going to have. With that being said, I've seen great soil results that just haven't ever resulted in the location of something underneath. So
And how,
sometimes
how
you
do you
can,
explain that? You just say the glacier moved? Is
yeah,
that how
definitely,
you?
until because it's tricky sometimes to trace back to the source of an anomaly in the till. That would be a common reason. It's just you're going to need to maybe tighten up your soil or your till samples. You're going to have a better understanding of how the glaciers moved. I mean, just as one other feature, glacial history, if you look at northern Canada as an example, we didn't just have one glacial episode. We had several sort of pulses. Glaciers they pulse forward, they pull back, and they pulse forward, and they don't always travel the same way. So it can create complications, right, of knowing how you trace things back. Um, it's always possible the deposit's eroded too. I don't like to default to that one, but of course, soil and till material is the erosional products of rock, and it is certainly possible you could have eroded the bulk of that deposit away, and so it's gone now, and you just can't find it. But I will say I've come across other ones that I just scratch my head at, not entirely sure why we weren't able to find anything. So.
Well, Rob, your website is MiningEssentials.com. You have your book there, but if for listeners that want to go more in depth, you have online courses that they can sign up and take at will, don't you?
Yeah, that's right. And you can find those on my website. They're hosted by a company called Thinkific, and I have a Mining Essentials short course, which is about 10 hours of videos distributed over about 60 some videos. That was actually recorded just a little bit earlier this year, so it's quite current. And I have a what's called the Mining Essentials full course, recorded a few years ago, but goes into more depth for those that are keen to learn a little bit more. So yeah, if you go to MiningEssentials.com, there's links, or you can go to Amazon directly. The book is sold on Amazon in the US and around the world, Canada and Australia. Uh, but you'll also find links to the online course at my website as well. So.
And if investors want it, they should get it today, right? We got to do the today only special because there's a limited supply with the COVID supply chain bottleneck, right?
Yeah. Supplies running a little thin. I'm going to have to get some more printed, but like everything, there's supply chain delays going on right now. So it's yeah, tricky time.
Yeah. Well, I appreciate your contribution to my show and thank you for educating us today.
Yeah, perfect. Thanks, Bill. Thanks for having me. Always happy to be here.